Okay, so I had a question about how I got the second derivative on number 1. So I'm going to kind of walk through that. So the first derivative, I went ahead and started writing it down, and then I thought maybe I should explain. So just in case. So this was a product rule right here, but then this right here is also a chain rule. So I took the derivative of the first, which is 1, left this one the same, and then plus left this one alone and did the derivative of this one, and that's this piece right here, which caused that chain rule. So I did e to the negative 3x as is times the derivative of that exponent, which is negative 3. So when I simplified that, I wrote it out as e to the negative 3x plus, really I could make that minus, so let me get rid of that. So that's minus 3x e to the negative 3x. That's probably the simplest you could write it. Okay, so now I have to do the derivative of this. So I'm going to rewrite this over here. So the second derivative, the derivative of this is just that chain rule that we talked about here. So that, I think I'm just going to write it. I already know that the derivative of that is this, right? This piece right here. So I'm just going to write that out as negative 3 and then e to the negative 3x. So that was the derivative of e to the negative 3x is e to the negative 3x times negative 3. So that's where I got this from. And then this minus sign, I'm going to leave that alone for a second. So this piece is kind of complicated. This is a product rule again. And again, it has this chain rule in it. So I'll go through step by step on this one. So let's say I do the derivative of the first part first. So the derivative of a 3x is just a 3, and then I'm going to leave my e to the negative 3x alone. And then really I should be putting this in parentheses. And then plus the derivative of the other one. So I'm going to leave my 3x alone, and I'm going to take it times the derivative of this. That's my chain rule. So e to the negative 3x times negative 3. So I just need to be careful with that sign, and I may have actually, I think I messed that up in my original problem. So I'll look at that. Okay, so this is negative 3 e to the negative 3x minus 3 e to the negative 3x, and then this would distribute into here, so that'd be a minus, but there's already a negative there. So this, when I multiply these, I get negative 9x, but this is already minus, so if I distribute that, that's plus 9x. And then this e to the negative 3x stays put. So then when I combine like terms, I can put these two together because they're both just e to the negative 3x's. So a negative 3 and a negative 3 would be a negative 6 e to the negative 3x plus a 9x e to the negative 3x, and I can't put those together because this one has an x in it. Okay, so then let me go back and check this old one. Yeah, that's what I got there. I thought maybe I messed this sign up, but I got it. So this was my second derivative. Then if you're looking for a point of inflection, what you're doing is you're looking for, that's basically a critical point on the second derivative. So when you do your second derivative, then set it equal to 0 and solve, I ended up with 2/3. And then that is, okay, so a point of inflection is where it changes from concave up to concave down, or concave down to concave up. So technically, I should have done a second derivative test here and said, okay, I'm going to check from negative infinity up to 2/3, and then from 2/3 up to negative, or up to positive infinity, and like checked my signs. But I promise you, if there is one that, if it comes out as just one single answer, that is going to be a point of inflection. If there were 2 or 3 of these, then I would check. But if there's just one, I would name that as my point of inflection and move on.